minutes. Let me clear these questions which we need to discuss today. Right, so these questions we will discuss. Oh, who got disconnected? Yeah, we got disconnected. Okay, so I guess these would be enough, and we will be skipping some questions so that we can cover this part very quickly. So you guys have already learned this motion in 1D, and I will just quickly or briefly revise that portion for you, right? So we have learned that what are the attributes or what are the parameters that defines the motion. Can you guys tell me what are the parameters, physical parameters or physical quantity that defines the motion of an object? Yeah. What are the parameters that defines the motion of the object?
Acceleration,
Yeah.
speed.
So yes,
Yeah.
distance, displacement, speed, velocity, acceleration. These are the parameters. These are the physical quantities that defines the motion, right? So the usual thing that you guys already know, I will not go into detail, but I will just give a quick glance to it, right? So distance and displacement. What is the key difference between distance and displacement? Can you guys tell me? What is the key difference between distance and displacement? Yeah, don't go by this definition. The other difference I'm talking about, not these ones. So these are right. These are these talks about the magnitude, but I'm talking about what is the key difference between distance and displacement. Yes, guys. You guys have forgotten. So the difference between distance and displacement is that it is a scalar quantity, right? And this one is a vector quantity. So whenever we are talking about displacement, we have to also talk about the direction as well. But the magnitude of displacement is the shortest path. So the displacement is shortest path. Distance is the actual or total path length. So this is magnitude wise, these are the two difference between them, right? And let's say the object is moving in a circle and I'm talking about these 2 points, right? So I'm talking about these 2 points. So the object was here at A and then it covers this 90-degree arc and then reaches here, right? Let's say the radius is R. So can you guys tell me that what would be distance and what would be displacement magnitude wise? I'm only talking about magnitude. What would be that from A to B? What would be the distance? What would be the displacement? Please tell me, guys. Calculate this one and tell me. Yeah. So, guys, what would be distance and what would be displacement? Please find it out and tell me quickly. Yes, are you guys solving?
Sir, I don't understand.
Okay, cool. So yes, it's all right. It's all right. It's totally fine. So let us understand this. So I'm asking that the object is moving in a circle, right? So this is the path that it is following. And let's say the object starts from here and reaches here, right? So then I'm asking that what is the distance? So distance would be this path.
Yeah, yeah.
Right, this path
Mm.
is an arc. So this is the arc length. And the displacement would be the shortest distance between them. So this would be the displacement. Right. So
Yes, sir.
distance is ABR and displacement is simply AB distance. AB. So we can find out this A using Pythagoras theorem, perpendicular square plus base square. So that we root R square plus root R square, which is 2R square, which is root 2R. Right? This is displacement A. Right. And what would be arc length? Arc length would be theta by 360 into 2 pi r. So theta is 90 by 360. So that is 4 and 2 pi r. So this 2 cancels. So pi r by 2. Distance is pi r by 2. Is it clear? Is it clear?
Yes,
Guys?
yes, yes, sir.
Yeah. So we see that for a same object, displacement and distance can be different. Right. So this is the main difference between distance and displacement. Distance is the total path length and the displacement is shortest path. Right. And yeah, but whenever we are talking about motion in 1D, so if the object is not returning, right? If it object is following the same direction, moving in the same direction, then distance and displacement, they are both equal, right? Magnitude of distance and displacement, they are both equal if the object is moving only in one dimension, in one direction only. So yeah, this is the key point, right? And in speed, what do we have learned? So we have learned that speed is distance upon time, and there are three kinds of speed. So one is uniform, the other one is non-uniform. And non-uniform is also of two kinds, average and instantaneous, right? So can you guys tell me what was the instantaneous speed? So uniform speed is distance by time, right? What is
Sir,
average?
speed at that
Yeah, so speed at that instant, but there's
Yeah,
a
yeah,
relation to that. So there's a specific relation and it is represented by V, right? So what is that relation? That is dx by
Delta.
dt. Yes, delta is related with the average one. This one is instantaneous, okay, and this one is the average speed. That is delta x by delta t. So whenever somebody asks you, somebody gives this value. Let's say x equal to 3t square plus 4t plus 5. So this is in parametric form, right? Whenever you are given the parametric form and they will ask you that what is the average speed, what is the average speed between 2 to 3 seconds. So you will be given two times, right? You will be given a range in which you have to calculate you have to calculate the average speed. So can you guys calculate the average speed for me? Please calculate the average speed for this part. What would be the average speed? Please calculate that and tell me what you guys are getting. I will just quickly go through these and then I'll talk about important results, right? Yeah, so this is the question. The distance is given in this form, and I'm asking that what is the average speed between 2 to 3? So whenever you guys have calculated, please tell me. Yeah, whenever you guys get any answer, please tell. So this thing you have done, that's why I'm asking, right? Yes, guys, did you guys get any result? So what do we have? We have x as a function of t, which is given as 3t square plus 4t plus 5. And we have to calculate average speed. So this would be delta x by delta t, right? Delta x is x final minus x initial divided by t final minus t initial. So x final would be x at 3 seconds, right? This is x final. So how much is this thing? This is 3 into 3 square plus 4 into 3 plus 5. So this is 9, 27, 12 plus 5. So how much is this thing? 17 and 27. So 44. Right. X initial is how much? X initial would be x at 2 seconds. So that is 3, 2 square plus 4, 2 plus 5. So this is 4, 12, 8 and 5. So 13 and 12, 25. So we have x initial, we have x final. T final, we already know that is 3. T initial, we already know that is 2. So what would be this thing? So average speed. This would be x final, which is 44 minus 25 divided by 3 minus 2. So this is how much? 9 and then 19 divided by 1. So 19 unit, yeah, meter not per square, but meter per second. Okay. So meter per second. So this would be the average speed, right, guys? Where did you guys get stuck? Is it clear?
Yes, sir.
Yeah. So these things, and if I ask you, so this is the same question, but if I ask you what is the speed? What is the speed at 4 seconds, or let's say 3 seconds, not 4 seconds. So what is the speed at 4 seconds? So what speed I'm asking in this one? What speed I'm asking in this question? So at instant, I'm talking about particular time, distance or speed at 4 seconds. So this is particular time. So this is instantaneous speed, right? So this would be how much? Let's say I write it as V. So dx by dt at t equal to 4 seconds. So how much is dx by dt? That is 6, right? 6t plus 4 and t at 4 seconds. So how much is this thing? This is 6 into 4 plus 4. So 24 plus 4, that is 28 meter per second. Right. So remember this is the crucial difference between instantaneous and average one. In average, they will talk about over a range. In instantaneous, you have to calculate at particular time. So is it clear, guys? Is it clear?
Yes,
Yes,
sir.
sir.
Yes. Yeah. And there is a universal formula for average speed as well. For so whenever the position is given in parametric form, then average speed is this one. But if they are not giving you this parametric form, they do not give you this function, right? X is not function of t. They will say that this is the speed at this time, this is the speed at this time, and they will ask you the average speed. Then you just calculate total distance covered by total time taken. So this is the universal speed, right? We will do a couple of questions to understand this one, but this thing is very important. So average speed has two definitions. It has two definitions. One is the total distance covered by total time taken. Other one is the parametric form. So whenever they give you parametric form, so average distance is delta x by delta t. Is it clear? This is very important. Is it clear?
Yes, sir.
Yeah, so this is, and then instantaneous speed we have discussed. Similarly, we have velocity. Velocity is uniform, non-uniform, and then average and instantaneous. So average is delta x by delta t. And then we have acceleration. So you have uniform acceleration and non-uniform acceleration. And then you have average acceleration and then instantaneous acceleration, right? So average acceleration is delta v by delta t. Instantaneous is dv by dt. So these are the things that we will discuss now. And what about the calculus part? So how is your calculus, guys? Differentiation and integration. You guys remember that this? Do you guys remember it? Or do you guys have any doubt in the integration and differentiation part? Because in the next set of chapters, we'll be using those topics very extensively. Okay, I will assume that you guys are pretty familiar with the differentiation and integration. And vector part we have discussed. So let's talk about the average speed. So average speed, but this is non-parametric. So x is not given as function of t, right? They will give you some values of velocities and some values of time or distance they will give you. So there are two things, right? The universal relation is that you have total distance covered, total distance by total time. So whenever I ask you about the average, what is the, for let's say I give you two numbers, A1 and A2, what would be the average of these two numbers? Yes.
A1 plus A2 divided by 2.
Yeah. And if I give you two speeds, let's say V1 and V2, so what would be the average speed? Yes. If I give you two speeds, V1 and V2, so then what would be the average? The obvious answer is that should be V1 plus V2 by 2, right?
Yes, sir.
Right, guys? But there is a twist to that, right? So we have to be very careful with this average definition. So this average is total distance by total time, right? And we will get to see what is the scenario in which the average speed would be V1 plus V2. So let's see that, right? So let's say that we have two parts journey, right? In this part, the speed is V1. In this part, speed is V2. But we are taking the measurement in equal time, right? So time is same. So we are measuring, first part is measuring in equal interval of time. Right. So this is T and this is T. Okay. So let's say this is A, B, and C point. So can you guys tell me for this AB journey, what is the distance? What is the distance?
V1.
V1 is the speed, right? V1 is the speed. Time is T. So we know that distance is speed into time, right? The object is not accelerating. We are assuming constant uniform motion, right? So the object is not accelerating. So distance is speed into time. So this distance would be, let's say x1, that is v1 into t. Then we have x2 distance. That would be v2t. So measuring in equal interval of time, but separate distance. Separate distances. Okay, now if we use this formula, so the average speed is total distance. What is the total distance? X1 plus X2. What is the total time? T1 plus T2. So X1 is V1T, X2 is V2T, and this is T plus T. So T is common, and this is V1 plus V2, and then this is 2T. So TT cancels, and we have V1 by V2 by 2. So this is similar to the average definition, right? Is it clear?
Yes.
Is it? So we apply this average definition only when the time interval is same. So you have the clock, and let's say you measure the velocity from 0 to 2 seconds, and then 2 to 4 seconds. So your time interval is 2 seconds, right? So in that thing, if you measure the velocities, then that is equal time interval. And in that one, the average is simply V1 plus V2 by 2. But there can be a scenario in which your time interval is not same. Time interval is not same, but distance is same. So the object is covering equal distance in different interval of time. So time interval is not same, but distance is same. Right. Then what would be the average speed? So again, we have this scenario, A, B, and C. And you have what? So this is V1 speed, this is V2 speed. Time is T1. This is T2. So what would be X1? X1 is same distance. So this is X, right? And this is also X. So same distance, right? Is it clear?
Yes.
Okay, so now let us find out the average speed. So average speed is total distance divided by total time. So what is the total distance? Total distance is what? What is the total distance, guys? Yes. Total distance is what? X plus X, right? And this is T1 plus T2. And if I write T1 in terms of distance, because they are same, right? So I should write it in terms of distances. So that would be X by V1. And this is T2 is X distance with V2 velocity or speed. So X by V2. Is it clear? Distance upon speed, that is time. Clear?
Yes.
Okay, so this is 2x. And what is this? So LCM is V1, V2. This is V2x or XV2 plus XV1. So what we can do is that we can write 2x. This V1, V2 goes upstairs. And then this is divided by x. X we can take common, and this is V1 plus V2. So x and x will cancel, and the average speed you will get, this would be 2v1 v2 divided by v1 plus v2. So we don't have the usual definition, right? So whenever the object is covering equal distances, then this is the average. Whenever the object is covering different distances in equal interval of time, then this is the average. Equal distances, then this is the average. Is it clear, guys? Is it clear?
Yes.
Okay, so quickly note this thing down. Quickly note it down, and we will talk about, we'll do a couple of questions, and then we'll talk about uniform acceleration. So quickly note it down, guys. Let me see the syllabus. So I have to complete this in one class. Let me check. Can I do that? Yeah, whenever you guys want me to scroll down, please tell me. Yes, noted, guys.
Yes, sir.
Okay, then please, is this one noted also?
Yes.
Okay, so now you guys do one calculation and then we'll move ahead, right? So the calculation that you guys have to do. So we know about all these things. What is distance, displacement, speed, velocity, and all the other things, right? Instantaneous speed, instantaneous acceleration, and all those things. So you guys have to calculate what is the average speed, right? For three journeys, three-part journey, and the speeds are V1, V2, V3 in equal distances. So this is the thing that you guys have to calculate. Quickly calculate this one and tell me what you are getting in equal distances. So three-part journey, V1, V2, V3 in equal distances. Calculate the average speed. So please find that out and tell me what you guys are getting. So A, B, C, D. This is V1, V2, V3. Distances are seen. X, X, X. Times they are different. Quickly do this one and we have to do a couple of questions, right? So quickly do this one. Yeah, quickly calculate this one and tell me what you guys are getting. Yes, did you guys get any answer? Okay, so ERAM is getting 3 V1, V2, V3 divided by V2, V3, V1, V3. Good. Okay, so ERAM is getting 3 V1, V2, V3 divided by V1, V2 plus V2, V3 plus V1, V3. So this is what ERAM is getting, right? So let's check that. So what would be the
Sir,
average? Yes.
so the last one is V1, V2.
Yeah, both. So this is addition, right?
In the denominator.
So yeah. So we have written V1, V2 is here, right? We can write 1 plus 2 plus 3, or we can write 3 plus 2 plus 1. They are same, right? So this is addition, so we can write it in this manner, right? So this is serial wise, 1, 2, and 3. So serial wise, something like that, right? You have written the same thing, right? So V1, V2, V2, V3, and V1, V3. Yeah. So all these are same, right? Addition, so they are same. Okay, so average speed would be total distance, right? Did you get my point?
Yes, sir.
Yeah, so these are addition, so we can write it in a proper manner, right? Is it clear to you? Okay, so total distance divided by total time. So total distance is x plus t1, t2, t3. So what do we have? This is 3x. This is x by v1. This is x by v2. This is x by v3. So if we take the LCM, right, LCM is v1, v2, v3. So v1 is divided, so this would be v2, v3, x I am taking common. Then this is v1, v3, and then we have v1, v2 as Iram got, right? So this x and this x cancels, this goes upstairs. So we have 3, v1, v2, v3. Here, okay, so did you guys note down this part? Noted. Yes, something is happening with my internet. Yes, noted. Alia and Nabil, did you guys note down this part? Yes, guys, are you there? Nabil and Alia, noted. Hello. Yeah. So done. Okay.
Yes, sir.
So then let's do some questions, right? So quickly do these questions, and then you guys will be able to understand what we were talking about. So yeah, let's quickly we will do one question and then we will move on. Right. So you have this question. Fifth, what you guys are getting. The idea is similar. You have to apply the same idea. Please do this question and tell me what is the answer you guys are getting. Yeah, please try this question, fifth one. Please calculate the answer and tell me what you guys are getting. Yes, so this is done in two parts. This journey is a two-part journey, right? So how much distance, let's say that total distance is x. From A to C, total distance is x. Then how much they are covering in the first part? How much they are covering in the first part? So this is 2 by 5 of x, 2x by 5. And then how much they are covering in the next part? So that is 3x by 5. Right? Is it clear, guys? Is it clear?
Yes.
And because they are traveling with different parts, right? In this part, and let's say time is t1, and this is t2. And the velocities are v1 and v2. So what is the average speed? This is total distance by total time. So total distance we have already assumed that is x, and total time is t1 plus t2. So how much is t1? T1 is this distance, 2x by 5 distance divided by v1. And then this is 3x by 5 distance divided by v2. So how much is this thing? So 2x by 5, so this is 2x by 5 v1. And then this is 3x by 5 v2. So LCM is 5 v1 v2. And this is x by. So 5 v1 cancels, and this is 2 v2 x. And then we have 5 v2 cancels, and we have 3 v1 x. So we can take common, right? This 5v1, v2 will go upstairs. And we can take x common from here. So this is 3v1 plus 2v2. So x cancel. Average speed is 5v1 v2 divided by 3v1 plus 2v2. So 5v1 v2, 3v1 plus 2v2. Is it clear? Clear, guys? Is it clear? Do you guys have any doubts?
Yes, sir. Clear.
Clear, sir.
Okay, so please quickly note it down. And then sixth question is the same. So we'll skip this one, we'll do the seventh one. And yeah, let's quickly move on to the other topics. Yeah, whenever you guys have noted, please tell me.
Done, sir.
Done. Okay, so yeah, you guys can try the sixth one at your home, but this is exactly the same. So now let's try the seventh question. So seventh question is, oh, why have I marked all the answers? Okay, so yeah. So what does this seven question say? So we have home and we have what market. So there are two places. So we have two-part journey, right? So we have this home and then this market. So one is in this question, one is onward journey, and then the other is a return journey, right? So a man walks on a straight road from his home to a market 2.5 kilometer away. So this distance we already know. That is 2.5 kilometer. And he is moving with 5 kilometer per hour. Right. He is moving with 5 kilometer per hour. And finding the market closed, he instantly turns and walks back home with a speed of 7.5. So returning speed is faster, right? So he wants to quickly returns to his home. So this is the thing. The average speed of the man over the interval of time 0 to 40 minutes. Right. So we have to find out, yeah, okay, so let's change it to the, yeah, let's keep it in this way, right? So we have to find the average speed. And average speed, we already know that is total distance divided by total time. Right. So we have to find out total time is given. Total time is 0 to 40 minutes. So total time is 40 minutes. Right. We have to find out what is the total distance, which is x1 plus x2. Right. So this would be the onward journey. And this is the return journey. So you guys will say that this should be 2.5 plus 2.5. No, but we have this time limit 0 to 40 minutes, right? So let's solve this thing, right? Let's solve this thing and find out what is the time to reach the market. So time to reach the market, what would be that? Let's say T1. Time to reach the market is T1. So time to reach the market. And that would be how much? Distance divided by this speed. Right. So how much is this time? This is 0.5 hours. 0.5 hours is how much? That is 60 minutes. So how much is this thing? So this is 30 minutes. Right. So in 30 minutes, he reaches this point. Right. And we have to calculate for 0 to 40 minutes. So how much time is the return journey? How much time is the return journey? Now, yes, guys, can you guys tell me how much
Sir, your voice is
time
cracking.
is the return journey? We have to find 30 minutes was reaching the market. My voice is breaking. Let me just stop this video. Yeah. So tell me, is it clear now? My voice? How is my voice? Is it clear now?
Yes, sir, it's clear now.
Okay, so I'm seeing that it takes 30 minutes to reach here. So what is the remaining time? Yes, what is the remaining time? T2, which is the remaining time, that would be 10 minutes. 40 minutes minus 30 minutes. So that would be 10 minutes. So the total distance we will take, so onward journey 30 minutes and return journey 10 minutes. So this is 10 minutes. Right. So what would be this distance x2? X2 would be time is 10 minutes and this is the speed. So speed into time 10 by 60. So this cancels, this is cancels. So 15 fours are and 15 fives are. So 5 by 4 kilometer. This is the return journey. Right. Onward journey is 2.5 kilometers. So what would be the average speed? Average speed is x1, which is 2.5, plus x2, which is 5 by 4, and then 40 minutes, which is 40 into 1 by 60. So this cancels, this is 10, 5 twos are, and 5 fives are, and then this is 0, this is 0, this is 3, and this is 2. So how much is this thing? 5 by 2 plus 5 by 4. So 4 is LCM. This is 2 twos are 4. So 5 twos are 10 plus 5 divided by 2 by 3. So this is 15 by 4 divided by 2 by 3. So this will go upstairs, this will go downstairs. So 45 by 8 kilometer per hour. This is the average speed. Is it clear, guys? Is this question clear?
Yes, sir.
Okay, quickly note down this part, and then we will do the parametric solutions, and then we will talk about acceleration. So quickly note this thing down. Yeah, whenever you guys have noted, please tell me. Yes, noted, guys.
Yes, sir, noted.
Noted. Yeah, so now let's do some parametric questions, right? Is increasing linearly, the particles start from the origin, the distance. If you don't, we have a simple question. X along is that acceleration of the particle is 2 meters from the origin, right? Okay, so the relation between time and distance is this. And so we will do one parametric questions, and then yeah, this is two-dimensional one. Okay, so let's do this 10th question. So in the 10th question, the acceleration as the parametric form given. And from acceleration, you guys have to calculate the velocity. So you have to calculate the velocity. So what is the operation that you guys need to do? Right, you guys already know that if you have the distance, right, and to reach the speed, what do you do? What do you do to reach the speed? From distance, how do you calculate the speed? You differentiate dx by dt in terms of t, and then you get v. And then to reach acceleration, what do you do? Again, you differentiate. You write dv by dt. So this gives you acceleration. Right. So to reach from position to speed, you just differentiate. From speed to acceleration, you again differentiate. That is how you do. But you want to go from acceleration to speed or velocity. Then what would be the operation that you will have to do? The opposite of differentiation, that is integration. Integrate. So V would be A dt. Simply when we want to calculate position or distance from velocity, so we integrate. Is it clear? Is this part clear, guys? Is it clear, guys?
Yes, sir.
Okay, so now let's do this question. Acceleration is given, and the starting point is also given. If the particle starts off with velocity u equals to the velocity at the end of 2 seconds. So t starts from 0 to 2. Time is given from 0 to 2. Velocity is u, and you don't know the upper limit, right? So upper limit you have to calculate. Okay, so let's calculate this. So we know that A is dv by dt. We take this thing this side. So dv is A dt. We integrated both sides. right? So this would be, in this one, we have to put the limit u equals to 2. So 2, and let's say you don't know the rest. So v, right? And this is from 0 to time is 2 seconds. So this is the limit, right? So what would be this thing? So this is v from v to 2, and then this integration. So that is 3t square plus 2t plus 2 integration from 0 to 2, and then dt. So this would be how much? This would be v minus 2, and then this is how much? 3t cubed by 3 plus 2t square by 2 plus 2t, and we have to put the limits, which is 2 to 0. This 3 cancel, this 2 cancel. So we have what? T cube 2 to 0 plus t square 2 to 0 plus this 2t 2 to 0. Right. How much would be this thing? So this is 8 cube plus this is 2 square plus this is 2 into 2. So this is how much? Oh, this is 2 cube, not 8 cube, right? So 2 cube, 2 square, and then 2 into 2. So this is 8 plus 4 plus 4. So that is 16, and v minus 2. So this 2 goes the other side. So 16 plus 2, that is 18 meter per second. So this would be the answer. Right. Is it clear, everyone? Is it clear? You guys have to use the idea of integration. Is it
Yes, sir.
clear? Okay, quickly note this one down, and then let me see. So we will do, which question we will do? Okay, 13th one is the similar one. So I will skip these, and then we'll do the 14th one, right? Okay, so quickly do this one. Quickly note down this one, and then we'll do the 14th question, and then we'll move on to uniform acceleration. Yeah, whenever you guys have noted, please tell me. Yes, noted, guys.
Yes, sir.
Okay, so now should we do this one? Okay, so this one is a simple one, right? This one is a simple one, so let's do this 17th one. So 17th one, what does it say? We have a particle moves along x-axis, so x is given as function of t, 4t minus 2 plus 8t minus 2 whole square. right? So this is how much? This is 4t minus 4 plus 8t square minus 2 cubes of 4t plus 4. So this is how much? This is 4t minus 4 plus 8t square minus 4at plus 4a. So this is the distance. Now if we calculate the velocity would be dx by dt. So this is simply 4 into t, that would be 1. This is 0. And then this is 2at minus 4a, and this is 0. So this is the initial velocity, right? So it is saying that the initial velocity of particle is 4, right? And if we put t equal to 0, so initial velocity would be t equal to 0. So if we put t equal to 0, so v at 0, this would be, this part is 0, so 4 minus 4a. So is the option A correct? Is the option A correct? This is not correct. So initial velocity is 4 minus 4a. Acceleration of particle is 2a. So let's find out. We have found that this is the velocity, right? So acceleration is dv by dt, which is 4 differentiation is 0. This is 2a and minus 4a, so that is 0. So acceleration is 2a, right? So this thing is correct. The particle is at the origin at t equals to 0. So if we put t equal to 0, then we have minus 4 plus 4a. So that is not at the origin, right? So this is also not true, and this is also not true. So this one is true. Is it clear, guys? Is it clear? So have you guys done the differentiation properly, right? I'm directly writing. So your differentiation should be correct. So if you guys have any doubt in this one, please ask me, right? Because I have directly differentiated it. Okay, clear. So yeah, quickly note this thing down, and then we will talk about the other topic. Yes, whenever you guys have noted, please tell me. Noted. Okay, so now let's move on to the other topic, which is uniform acceleration. So whenever you guys have uniform acceleration, you have these kinematics equation of motion, right? So these equation you guys are already familiar with. So I will not discuss this in detail, but there is one more formula, right? There is one formula I will discuss about that. So whenever you have uniform acceleration, right? Whenever you have uniform acceleration, so 4 equations you guys already know, 3 equations. These are called equations of motion, and particularly these are Newton's equation of motion, and these are also called kinematics. Kinematics of motion is u plus at, and then you have s is ut plus half at square, and then you have v square minus u square, that is 2as. But there is one more, right? fourth one, and that is distance at nth seconds or nth time. Right, what is that? So let's try to find that out. Right, all these three equations you guys already know, so let's try to find out the fourth one. So we have, let's say this time is, total time is n seconds. Right, this is n seconds. And then I have this time, 1 second before. Right, from here to here, that is 1 second. So what would be this time? From here to here, what would be this time? What would be this time?
N minus 1.
N minus 1. Absolutely correct. So good. So n minus 1 seconds. So what I will do is that I want to calculate the distance traveled in this time. Distance traveled in nth second, right? So in the last second, this is the last second, last 1 second. So this is the nth second, right? So if I want to calculate this distance, what I will do is that I will calculate this distance total minus this one. So distance traveled in nth second, that would be distance traveled in n second minus distance traveled in n minus 1 second. Right, is it clear, guys? So let's try to find it out. I have initial velocity u, I have acceleration a, and yeah, this is the only thing that I need. Right, time is n minus 1. So for Sn, time is n. For Sn minus 1, time is n minus 1. So let's put this value. This would be un plus half an square, right? Minus of this would be how much? This would be u, time is n minus 1 plus half an minus 1 whole square, right? So this is how much? This is un plus half an square minus un minus u plus half an square minus 2n plus 1. And this would be how much? Un plus half an square minus un minus u plus half an square and minus of half a 2n and plus of a by 2. Right. So these are the things that I'm getting. So what will I have? This is un plus half an square minus of un plus of u minus of half an square plus of a to n by 2 plus and that is minus of a by 2. Right, so un will cancel, an square cancel. So u plus a by 2 into 2n minus a by 2. So I can take a by 2 common, and this is 2n minus 1. So this is the distance traveled in nth second. Is it clear? Is it clear, everyone? So if it is clear, please quickly note this one down, and then we'll do a couple of questions. So quickly note this thing down. So this is the distance traveled in nth second. Yeah, quickly note it down and then we'll do some questions. Yeah, whenever you guys have noted, please tell me. Yes, noted, guys.
Yes.
10. Okay, so now let's do couple of questions using the kinematics of motion. So all these four equations we will use, right? All these four equations we will use, and we will try to find out, right? We'll try to find out the answer of certain questions. So let's do all these questions. So this is the first question. A particle experiences. Oh, so I have our next class will start in a few minutes. Okay, so next class will start in a few minutes. So give me 2 minutes more, right? Give me 2 minutes more and then we'll end. So yeah, because we started late, right? So give me 2 minutes more. And who got disconnected? So, oh, Edom got disconnected. Okay, so yeah, 2 minutes more and then we'll end, right? So let's do this one question. Okay, so in this one, a particle experiences a constant acceleration for 20 seconds after starting from rest. If it travels a distance s1 in the first 10 seconds and a distance s2 in the next 10 seconds, then we have to show what is the correct relation between s1 and s2. So I have to make two blocks, right? Oh, what happened? Okay, what? Oh, so I have to make two blocks, right? And this is first 10 seconds, and then this is another 10 seconds. And what is this distance? So this is S1 distance, and this is S2 distance, right? What do I know? So I know that this, I know that the acceleration is same. This is A acceleration, this is A acceleration. And it is starting from rest. So this is 0. U is 0. So I can write S1. S1 would be how much? S1 would be UT plus half AT square, right? And U is 0. This part cancels. Half A, and I know that time is how much? Time is 10 seconds. So 10 into 10, this will cancel. This is 5. So this is 58. Right. Now I know that, now let's talk about the whole journey, A to B. So A to B, AB would be UT plus half AT square. So AB is how much? That is S1 plus S2. And this is how much? U is 0. This is cancelled, half A and T square. So T is how much? T is the whole journey, 20 into 20. So this part cancels, right? And this is how much? 10. So this is 200 A. And this is S1 plus S2. I know that 50A is S1. So if I multiply this by 4, so 4S1 would be 200A. So if I put this value in here, So S1 plus S2 is 4S1. So this will go the other side. So S2 is 3S1. So S1 is S2 by 3. This is the relation, right? Okay, so I will stop here and we will continue from here in the next class, right? Quickly note this one down. Whenever you guys have noted it down, and if you guys have any question, then we will talk about that, but I'll stop here, right? Because you have